So now in this video, we're going to look at how easy it is to charge a battery pack with this Hobbymate charger. It also does a whole bunch of other stuff. So I took the XT60 connector here. I built this myself. You can find ones with wires hanging off them or whatever, and crimp whatever you want on it. Maybe there's already an attachment that you like. But in any case, the red one here and the black one right there, they go to the XT60 there, and which I plugged into the charge port, and so I put them to those two. And then the last video I showed that I just stuck those just plain wires to the 5 connection points. So we have where this one negative side of this battery comes. The positive side down there is connected to the negative side of this one down below, and then we have this middle connection there. There's another connection down there, and then this connection up there, and you can see the string of colors there that measure those 5 points. And in that way, the charger here can measure the voltages. We'll look at that coming up. So this XT60 up here, that's going to my bench power supply. I have it set to 18 volts because we're going to be charging, that's as high as it goes for one thing. We can go up to 30 volts, but we're going to be charging up to 16 point, almost 8 volts, maybe 16.8 volts. So we need a little bit higher than that. So in any case, we have a charger there. In the last video we looked at measurer. The charger is going to show us the measurements too. So we go to charger. It's pretty easy. So I already set the settings for the most part. We'll click again, and so before we charge, I like these settings here. As I said before, we're going to charge it to less than 16.8 volts, and so we're actually going to charge it 4.15 volts for each series of batteries. There's 4 series batteries, so you multiply this by 4. The battery pack's going to be 16.6. Now we can click this and go up to 14.2. That's the maximum you want to charge lithium ion batteries, but some LiPo batteries might allow you to charge it up higher to 4.25. We definitely don't want to do that. 4.2 for our purposes. If you're doing the same thing I am, that's the maximum you want for lithium ion. And going a little bit lower is perfectly fine. And they don't hold 4.2 volts anyways, all the ones that I got, so they drop down to 4.1, I think, afterwards. So in any case, this is the voltage that we have right now across the 4 of them. So charge, the current is 1 amp. I'm pretty happy with that. We have 3 parallel batteries in each series of batteries, and so each one of those parallel batteries, this will give us 1 amp of current through that series, that series, that series, and that series. Since there's 3 in parallel though, that 1 amp will get split up 3 ways, so about 0.33 amps. So that's, I think, decently low for charging these EBL lithium ion batteries. And there's a lot of batteries that can handle a lot more current, so you have that option here. That's what I set. I think it's normally higher, but there we can click it, and I think it goes up to 8 amps. I can spin it pretty quick so we can go check. That goes higher than 8 amps. My bench power supply, wow, my bench power supply, okay, 15 amps. It only goes up to 3 amps anyways, so this would not output that much. But in any case, we're just going to stick with 1 amp. So if we had a lot more batteries in parallel, we could go pretty high in current. So we're going to leave it there. We don't have to worry about discharge right now. Let's click this. There we go. It's set. And now we're going to click, get it to charge, and click there. And so right there it's asking you for the voltage. That's the multiplication that we did before, 4.15. And so that's 4 batteries in series. It knows there's 4 batteries, and we click OK actually. So there's automatic here, and so I think right now it's looking at the voltages, and it can tell that there's 4 batteries. I think we can do like 1, 2, 3, 4. Yeah, we can do that and set it that way, I guess. But probably best just leave it at auto. So in any case, let us go to charge and start charging. So now, as you can see, I'm going to be careful not to bump this. I think I have a loose connection somewhere, and earlier I bumped it, and you can see that we have, it's about 15 volts at the moment, and I did a little bit of charging before I filmed this. Also, every once in a while you see some things highlight. You can tell those two batteries are a higher voltage than those two, so I think it's telling you that it's actively doing something to try to get the one that's a lower voltage to their voltages. So it's probably cutting a little bit of current or something, letting a little current go past them or something like that. I don't know exactly what it's doing. You're going to see the temperature rise when it gets hot enough. There's a couple fans. They're a little loud. They're not bad in person. The camera might the camera seems to pick up fan noise pretty well, but they're really not that loud, but you will hear them when they kick in. I think it'll kick in at 42 degrees Celsius, pretty close to this. Now, there's the fan. Now the current is flowing. Over time, it's measuring how much current has flowed. And so we are 1 amp right now, pretty much spot on. So after an hour, this is going to say probably 1,000 milliamp hours, which is the same as 1 amp hour. I don't know if it changes to amp hours at any point. But so if we charge this for 2 hours, it will say 2,000 milliamp hours or 2 amp hours. And so what that means is you take the voltage that you started at, and when you charge it, so you get the discharge voltage, whatever it's discharged at. When you charge it, it's going to take a certain amount of current, a certain amount of time to charge it. And you can expect about that same amount of current powering something else for about the same amount of time. And so it will give you an idea based on how much current something is using. When you multiply the current by the time, you can either use that for charging to see how long it's going to take to charge for one, but more importantly, how long it's going to be able to power something, because lithium-ion batteries, they're very close to the same. Whatever energy you put in, you don't get exactly the same amount of energy out, but it's close. So that's kind of helpful. And you can see how long it took to charge, and you can see the wattage too. So this gives you a lot of information. The nice thing though is it's looking at the voltages of all the batteries and making sure, first off, that they're about equal, and then also it's using that to make sure none of them get above, in this case we set 4.15 volts, but normally it's about 4.2 volts. Some of these chargers, not this specific type or anything, there you can tell a even louder fan kicked in, but a lot of chargers, they try to get every battery to 4.2 volts. Some of them don't have balancing though, and so you may get to 16.8 volts, and then one of them might be over 4.2 volts and one or more might be under 4.2 volts. There might be an imbalance, which is bad. That's why I like that this one you can set the voltage, slightly lower, but even though you can only set it slightly lower, it monitors them anyways, so you have nothing to worry about. It does all the work for you. So, in any case, I think I covered pretty much everything on there. Only 4 minutes now that it's been charging, and we got the milliamp hours. And of course, remember, with milliamp hours, you don't have to go by the same amount of time. If you use twice the current or charge with twice the current, it will just last half as long, but you're using about the same amount of energy. So milliamp hours is a multiplication of current by time, and in this case hours, and so you can make those hours fractional or multiple amount of hours, however you want. Also, these batteries are not high current batteries. It's probably best to keep them to 0.5 amps each. And so when you have milliamp hours, they have 3,000 milliamp hours written on them, so that's 3 amp hours, but you wouldn't want to put 3 amps through them in an hour. They'd probably get way too hot. That'd be bad for them. So I think it's about half of an amp per battery. And so you can put a bunch of them in parallel though, and then you could get 3 amps from 6 parallel batteries, and that would be 3 amps total. But each battery is only providing 0.5 amps. So their amp hours add up in that case. But this is nice because you can charge it and actually look at the milliamp hours that you actually took to charge it. And there's also discharge options. I think they do the same thing. So you could look at how much current in milliamp hours you get while you discharge it. So in any case, hopefully you found that helpful. And this stuff is kind of overwhelming at first, but once you get a grasp for it, then it gets really easy. The main danger is that it's really easy to accidentally short circuit something. Extremely easy, no matter how good you are at getting it. I read a lot of stuff from experts, and they all said, you know, like it hadn't been that long since they short circuited or something. It's really easy to do. So with the battery pack, take great care not to mess it up. But after that, once you have it built and everything, if you cover it so it can't short circuit or whatnot, you have good monitoring equipment, and you learn how much current and power and stuff they can handle safely, then things go pretty smoothly. So thanks for watching, and I will see you in the next video.